For question 5, under the chemical equilibrium section of this review, you're asked to find the equilibrium constant of the reaction shown here. We're given some data to work with. We're given that 2.4 moles per liter is the initial concentration. Of hydrogen gas. We're told that you have 100 grams of iron oxide. Okay, be careful, there is a typo in this. There should be a 3 in there in the reactant side. And we are told that the equilibrium concentration of hydrogen is 1.0 moles per liter. Sorry, not final, but equilibrium. Given this information, we can both write our equilibrium expression and we can start our ICE table. So the equilibrium expression is KQ equals, and it's always products over reactants. But remember, you're talking about concentrations, and you can't measure the concentration of a solid. So iron oxide and iron itself are not included in this expression, which means that this data is actually irrelevant. So products, we've got H2O, and we've got H2, both not to the power of 2, but to the power of 4. So those are their coefficients. We can also set up our ICE table. We've got 4H2 gas, which is the one we care about, plus Fe3O4 solid, 3 of those, and 4 water molecules in their gaseous state. So for this purpose, we don't really care about this section here. Those are all solids. So we can just fill in the rest. Initial concentration, change in concentration, equilibrium concentration. We can fill in 2.4 moles per liter. We can fill in that equilibrium. It is 1.0 moles per liter. So we can determine the change is a loss of 1.4 moles per liter. Initially, our reactants should have 0 concentration. They should not be present. The change should be proportional, so the coefficients on these match 4 to 4, so the change should actually be the same, but products are going to increase, so plus 1.4 moles per liter, which gives us an equilibrium concentration of 1.4 moles per liter. Going back now, I can calculate my equilibrium constant. It is 1.4 to the power of 4 divided by 1.0 to the power of 4. Sorry, the sounds kicked in here. So 1.4 to the power of 4, I plug that into my calculator, and I get 3.8416. But I do not keep all of these. I can only keep my significant figures. Since the 100 grams was not included, I can ignore that in terms of determining my significant figures, and I'm going to look at the 2 values I was given. Those are both 2 significant figures, so that's what I will keep. I'll cut it off there, and my answer will be 3.8. Remember, there's no units for equilibrium constant.